Okay, so perhaps by now we have a general idea on how to keep all these separate. And I think perhaps one good way to try to keep these separate is, especially when you're thinking of asparagine and glutamine. I don't know if I'm pronouncing that first one right, but what does it mean to have an amine group? Yes, that's true, because that's why they're called amino acids, because since it has an amine group, we know we're talking about amino acids because it has the amine group on the left side. And a lot of these follow, per se, again, the same pattern. So if we're dealing with amino acids, here's your amine group right there. Okay, so typically draw them like that, and then I don't know if that carbon has a specific name, but then here is your acid side. Give me its name, it's amino acid. And for the most part, a lot of these follow the same patterns, whether it's glutamic acid, what's the other acid? Aspartic, and then glutamine and asparagine. Some of the same patterns that they follow is there's going to be at least one CH group on there. So go ahead and pick any one of those four. This is just something to hopefully help you out here. Glutamine, asparagine, aspartic acid, or glutamic acid. Okay? So we know that there's at least one CH group on there, but if we're going to be talking about glutamic acid, well then that means there's going to be one more on there, okay? And then one more again, okay? Oops, I didn't do that right, did I? You can do that, that's fine. You're talking about down here. Yeah, that's fine. Yes, I don't mean to say yeah, but yes, that's absolutely fine. Okay? So then what we mean by that is there's at least one CH group on there. So if we were to move this up one, then according to our, if you want to call it alphabetical order, then we know we don't have glutamic acid anymore. We've got what instead? Aspartic acid, okay? So I don't know if that's something that can possibly help you out. It's just realizing that for a majority of these, especially on page 601, you're going to have at least one CH2 group on there. Then how you differentiate between them would change. Because then if we're talking about asparagine or that of glutamine, okay, we know there's at least one CH group on there. And if this is asparagine, then we've got that double bonded oxygen on there. Then, okay, and then there's a nitrogen with what? Two hydrogens, okay? So again, they at least have one CH2 group on there. Okay, probably better take roll first. Okay, now that we got that done, and I know some of you will be tuning in later. We just made the comment that, okay, I know everyone's busy. Just have to come back and watch this a little later. So what we have on the schedule today is linkages, okay? So what that would mean then is we know that what are the building blocks for proteins? Amino acids, just like what we're talking about here. So there's got to be a way that these will link together. And what happens is, like we said yesterday, a lot of these follow the same type of pattern that we've been talking about this semester. Okay? So what that would mean is, what is esterification? Making an ester. So what is it that you have to form an ester? Okay, so there's our clue right there. If we're talking about amino acids, which we are, this is based upon prior knowledge with the idea of, okay, let's take a stroll down memory lane. It's probably been a while since we've seen this. Okay. All right. So what is this? That's an acid, propanoic acid. Okay. So what type of alcohol would you want on here? Okay. So to keep this simple, and it seems like I always run out of room there. Okay. How is it that these two link? Do we remember?
OH comes off.
Okay. So what happens is this entire, no, it's that entire molecule, but the bond still has to stay there. Okay, so that comes off, and what about this side? Just the H. Okay, so therefore, what we have linked here with this oxygen will then bond with this carbon then. So what do we got? The name of this ester. Why are you right? What comes first? Just say that again, please. Yes, the alcohol side. Because I didn't think that's what you said earlier.
I said the one without.
Oh, okay. Kind of like the L's, kind of big L and little l. So as we can see, okay, the alcohol side gets named first. So like you said, butyl propanoate. Okay? So if we take this same content, okay, just the same knowledge that we've learned already. Okay. So I've noticed some of us rewriting these, making flashcards, like, or something to that effect. Again, keep doing that. Okay. So even in my own examples, it is hard to keep these straight. So let's see here, different color, hopefully one that will show up. Okay. Back row, an amino acid. Okay. Why'd you have to pick a hard one? It is? Glycine is, not glutamine. All right. But regardless, okay. And for the, what do you want to say, maybe a minute and a half that we had started without young ladies coming in here, what is it that we said you can use as a clue? Well, at least try anyway. Each and every one of these amino acids follow a general pattern. There's always going to be at least one what off this carbon?
Oxygen.
Well, that's part of the family. There's at least one CH2 group, okay? But in this case, you had said glutamine, so since that comes after, and I don't know how you pronounce that, asparagine, that's what I always say, okay? I'm going to go with no. Okay, So with that then, so since there's at least one CH2 group, if we did one more, okay, then we're looking at our asparagine. But since you said glutamine, that means we have at least one more carbon on there. There it is. But what is it that is branching off of that next carbon? Because maybe I got that wrong. I do have that wrong. Then what's branching off of here? Double bonded oxygen. Okay, so running out of room here. And then since it's called glutamine, how can you use that to your advantage? Since the suffix is what? Amine. So that means, kind of talking in circles here, that means you've got an NH2 group on the bottom. So I'm running out of space here. And that's probably not going to show up very well, but we'll do our best. Okay, so I have to take my word for it. There is a nitrogen with 2 hydrogens on there. Okay, then, okay, another amino acid. All right, yeah, we like the easy ones. That's true. You know, I was going to say that. Someone pick one that's a little easier. Okay.
When you're writing like the two group on there, you just do the nitrogen and then the two.
2 hydrogens.
Yeah.
Yes.
On the lines.
Yes, that's correct. Okay. So then we follow the same practice here. Okay. There is our amine group. Okay. So what is it that we're going to draw on here to make this glycine? Nothing. That's right. I didn't know if we would pick up on that, thinking if we asked in that manner, what are we going to add to this carbon? But we don't need to because it's glycine. Okay, so using prior knowledge with esterification, do we see a similar pattern between amino acids as opposed to esterification? The answer to that would be yes, but how can we take this knowledge here and apply it down here, do we think? Okay? So what that would mean then, okay, this comes off, okay, and then what from glycine then? If we follow this pattern. Yeah, one of those hydrogens, okay? So that's how we would illustrate how these are going to be linked together. And I suppose it's just one of the ways we could say that just follow the chemistry. These all follow a similar pattern, and this is one of them that we would say follows this similar pattern. Okay, so now we can erase this. Okay. So now what we want to do is link them together now. Okay, we're going to take this and illustrate it, how to link them together. So there's our nitrogen, okay, carbon, and I should probably write really small, just so that I don't run out of room like we did before. Okay, now careful with this. Is this right so far? I did that intentionally. Right when I wrote it, I said, "That's not wrong," or excuse me. Right when I did that, I said, "That's not right." And I'll say, see if why is that not right? Yeah, we can't have a hydrogen there because that's where a double bonded oxygen is. Okay? Then, what is going to be here? Remember that OH group is there, but that's gone because of that dehydration that took place. Close. Well, yes, I suppose you could look at it that way. Because I had hydrogen on my mind because I pointed that in the box. So there's our next nitrogen. Okay? And then how many hydrogens do we have left? Okay? So then typically we just illustrate, rather than putting anything on this side, I think that could be confused with the bonding that's going on here. So I just stick it on the bottom like that. That hydrogen that was here, we put down here. Okay? So then there's our next carbon, which is here. So there is 2 amino acids linked together. That's probably not a protein yet. Some proteins are going to be way more complex than others. And no one in here has been in zoology. I think maybe we talk about it in biology. But some of the more complex proteins that exist in nature would be possibly something, see if you can think what these might have in common. Now I'm drawing a blank all of a sudden. Oh, the Komodo dragon would be one. The copperhead would be another. The black widow would be venom. Venom is a very complex protein. Now, whether it has an effect on bleeding, whether it has an effect on the nervous system, or whether it has an effect on pain, you could say, or a neurotoxin, a myotoxin, or a hemotoxin. A lot of them proteins that are, a lot of them enzymes that are proteins, you could trace back to here if you had that capability. But for the most part, it's just way too complex for a computer to try to decipher. And I think that would be really interesting in some sort of research to be able to do, is if there is a type of venom that creates that much pain in a person, which there is, if someone is envenomated, how do you typically treat them? There's 2 things that can happen. Well, 3 things. The antivenom is probably the most common aspect. The next one would, let's hope that the kidneys can filter that out, because that can happen as well, filter out that venom. And unfortunately, the third one could be possibly succumbing to the effects of that venom, because that can happen too, which is rather unfortunate.
What do you call the new thing that you made? Like, is there a name for it?
Linkage.
Like, you know, all those, like, whatever, propanoate on the other
Oh,
ones?
no,
Name
these,
for
no, once, if you were to start to name these, you'd be naming a protein. This, we just call this linking. Linkages or linking. Yeah.
You'll never have to name?
You'll never have to, just the amino acids you name, not the protein. Because if we did that, one of the things we would say is draw this 3 amino acid protein, which means maybe it's lysine and asparagine and glutamic acid. Then you just illustrate how that's linked together.
So if you add another one, you just do the same thing.
You just do the exact same thing. Okay, so what that means, go ahead and pick another amino acid. Serine, okay? And maybe that's how you pronounce it would be correct too. I really don't know. Okay, so let's break it apart into its pieces, then we'll put it up there. Okay, so we said serine, okay? Because the more you write these out, the more familiar you're going to be with these, but the unfortunate side is chances are when May rolls around and you're done, this will be in, hopefully, there's no such thing as a midterm memory, I don't think. Okay, your short-term memory, okay, we don't need to know this anymore, it's gone. Okay, but the basic premise will probably always be there, how to draw these amino acids, but here, again, is where they differentiate. So, you had said serine, okay, which, what was the glue, the clue that we gave yesterday? How many carbons?
1.
Just 1, okay? And then what is attaching onto that carbon? Okay? So now there is our serine. Now we're going to take that up here, take this content and put it up there. So this would disappear. There is our next nitrogen. I had to think about that for a moment, and then there's nothing down there. This can be erased now, because now we have linked those together. Okay, so that is how this linking takes place.
Will this be on private quiz 12?
This will be on Friday, yes. Okay, not only just drawing separate amino acids like this or this, but then another part will say draw the protein with these 3 or 4 amino acids and show how they link together. That would be Friday. Okay.
They're all in the same way?
Like this here? Yes, they all bond the same way. Yep. So, front row, we're good. Second row. Oh, I didn't know any other classes did that. Okay. Did one of the juniors tell you that?
No.
Oh, maybe I did. Okay, back row. I don't want to just figure or presume things. Okay. All right. So we shall catch up to you next time. Also, tomorrow's an early out, so I might go over to the lab maybe this afternoon and try to put the cat on there. We'll see how that goes. I know I said Wednesday, but with tomorrow being early out, I might try to do that tomorrow, or today, excuse me, today. All right, catch up to you next time.